Back for our video in section 6.1, we're now going to look at weight of 3-year-olds. So the weights of 3-year-old females closely follow a normal distribution with a mean of mu equal to 30.7 pounds and a standard deviation of 3.6 pounds. Randomly choose one 3-year-old female and call her weight X. What is the probability that a randomly selected 3-year-old female weighs at least 30 pounds? When we're talking about weight, notice this wouldn't be discrete. It would be a continuous distribution because you can take on various weights. You can weigh 30.7 like we have for our mean, or you can weigh 23 or 23.2 or anywhere around there. So it's more of a continuous distribution. In fact, they told us that this is a normal distribution, which we already know a normal distribution is continuous, and we know how to work with normal distributions. First, remember that when working with normal distributions, you want to state the distribution in your answer. So we know that this is a normal distribution with a mean equal to 30.7 and a standard deviation equal to 3.6. Now it's asking, what is the probability that a randomly selected 3-year-old female weighs at least 30 pounds? So we're trying to find the probability that X is greater than or equal to 30. Now, if we remember back to the work that we did before, it's helpful to look at the normal curve. It's not the best curve drawn there, but giving us just a picture of what's happening here. We have our mean of 30.7, and then our standard deviation of 3.6. So, because I'm looking at probability X is greater than or equal to 30, that's really close to 30.7. One standard deviation below would be 27.1. So we know this answer should end up being X is greater than or equal to. We'd be looking at this area over here. Just from looking at that, that should tell us that our answer, our probability, should be really close to 50%. So let's go ahead and go through and do our calculations. We're going to start by, as we've done before, looking at our z-score. So observation minus mean divided by standard deviation. And if I put that into a calculator, I'm going to find that I get negative 0.1944. Then from my z-score, I can go to table A. And if you remember how to use table A, I'm going to follow my z-score, go down to negative 1.9, and that's going to be way over here, and I get 0.4247. Okay, but that would be the area right here. So the probability that X is greater than or equal to 30 is going to be 1 minus 0.4247. And, sorry, putting that in calculator real quick, we get 0.5753. So as we saw before, should be really close to 50%. We got something pretty close to 50%. And then we're going to answer that in context. So what is the probability that a randomly selected 3-year-old female weighs at least 30 pounds? There is about 57.5% probability a randomly selected 3-year-old female weighs at least 30 pounds. So again, as we saw in the last video for chapter 6, we're going to be applying what we've learned previously of variables and univariate data to these now random variables. Where the variables come from has changed, but how we will work with them has not.